Unit 6 in our class was all about systems of equations. So let's remind ourselves what a system really is. A system is just when you have two equations working together. The solution to a system of equations is the point, xy, that satisfies both equations. Okay, so anytime it says solve, or what is the solution, your answer is going to be an x and a y. So here's some examples. When you have a system of equations that has one solution, that means that they're just going to intersect in one spot. So for example, you may have y equals negative 2x plus 1 and y equals 1/2 x plus 3. I'm completely making those up, and those do not match the graph. But again, these would be two equations that are going to intersect in one point, so they have one solution. Okay. You also had systems where there were no solutions. That was when technically, when you graph them, the two lines are parallel. They're never going to intersect. Okay, this would be when you have a problem like y equals 2x plus 7 and y equals 2x minus 10, something like that. Because they have the exact same slope, they're parallel, they're never going to cross, so they don't have a solution. No solutions would be your answer there. We also talked about when you have infinite solutions. This is when you have a equation that really just appears twice. It's the same equation twice. So y equals negative 2x plus 1 and y equals negative 2x plus 1. You just may not realize it's the same equation until you convert it into slope-intercept form. But that's going to have infinite solutions because it technically intersects everywhere. All of these points are on both of those lines. The last thing in this unit was when we had a system of inequalities, and that just appears as two shaded areas overlapping where you really care about the double shaded region. So the things that are solutions here would be any point that is in this double shaded region. Okay, and remember too, we talked about the solid and dotted lines. Solid lines are fair game, dotted lines are not. So we learned 3 different methods to solve a system. We learned substitution, elimination, and graphing. So I'm going to demonstrate those 3 here really quickly. But remember that on your STAR test, you can use a calculator, and graphing is just going to be your easy way to go if it's easy to graph. Okay. So substitution is where you plug one equation into the other. So for this set of equations that we have here, I need to isolate a variable. So I'm going to move this 2y over. So I've got x equals negative 9 plus 2y. I'm going to make my writing a little smaller. So what I'm going to do now is I'm going to plug all of this in for x on the top equation. So negative 5 times negative 9 plus 2y minus 7y equals 11. So now I just distribute and pretty much just solve an equation that has one variable. We'll subtract 45. So negative 17y equals negative 34. Divide both sides by negative 17, and y is 2. Now that's not my final answer because the answer is supposed to be a solution, a coordinate, an x and a y. So I'm going to then go and take this y and plug it back in to one of my equations at the top. Okay, and when I do that, I get an answer of, I think, 5. For negative 5. Negative 5. Okay, so that's substitution. Let me switch colors here. Elimination is when we added the two equations together in order to eliminate a variable. What you had to have for these was not only standard form, where they're both lined up, but also have a variable that is ready to be eliminated. You needed them to have the exact same coefficient, but with opposite signs. So for this system, I need to take this top equation and double it. What that's going to do is create positive 16x minus 12y equals negative 40. Now I'm ready to add these together. So I'm going to just ignore that top equation. When I do that, my x disappears. And that's what I want because now I only have one variable and I'm able to solve this system. So y equals 2. Okay, then I'm going to go, just like I did a second ago, and plug it back into one of the original equations. So we'll just do that bottom one. Negative 16x plus 7, plug in the 2 equals 30. So I'm going to subtract 14 from both sides. So negative 16x equals 16. So x is going to equal negative 1. Okay, the last method is graphing. And this is again where you just put the two problems on the graph and then you find their intersection. So the first one, we have negative 3x plus 4. So there's my y-intercept of 4. Do a slope of negative 3. Okay, my next equation was 3x minus 2, so here's minus 2, positive 3x is my slope this time. So I connect those, and I see that my intersection point is at 1, 1. So my answer would be that 1 and 1. So those were the three methods that we used. Okay, again though, I would graph if it's easy to graph on the star, just because your calculator will do that for you. However, here's an example of a star question where it wouldn't be quite so simple. So this question, 2 customers went to a post office to buy postcards in large envelopes. Each postcard costs the same amount and each large envelope costs the same amount. Here's the information they give you that you're going to use to make 2 equations. So it says the first customer paid $12 for 14 postcards in 5 large envelopes. Well, I need to turn that into an equation. I'm going to make postcards my x and envelopes my y. So 14x plus 5y costs $12 for that first person. The second customer, they paid $24.80 for 10 postcards and 15 envelopes. Okay, well, I've created my system. I have a nice pretty set of equations here for my system. However, I need to solve it. What was the cost in dollars of each large envelope? In other words, I'm looking for the y. Well, I need to solve this using one of those methods, and honestly, this is more set up for elimination than it is for graphing. In order to graph this, I would have to change everything to y equals mx plus b, and that might take too long. So instead, I'm going to solve this using elimination. I'm going to multiply this top equation by -3. Okay, so by doing so, I'm going to change this into -15y, which is going to help me eliminate that y variable. So, when I add these together, I'm going to get -32x equals, I'm using a calculator just so I don't mess up my video and have to start over, -11.20. Divide both sides by -32, and x is going to equal 35 cents. However, and you'll notice that's an answer choice, they wanted the cost of the envelope. That's the y. So I need to go plug that in and get the y value, because that's really what they're looking for. So I'm going to write 14 times 0.35 plus 5y is supposed to equal 12. So we're going to solve this instead. I'm using my calculator again just to save some time in this video. So I get 5y equals 7.1. Divide by 5, and y ends up equaling 142. So my answer would be A.